Hello students, can you tell what this is? Yes, this is a linear equation. It is a linear equation in one variable, that is x. Now can you solve this equation? We can write it as 2x equals minus 3, which implies x equals minus 3 by 2. Now students, can you tell what this is? Yes, this 2 is a linear equation, but this equation has two variables, x and y. So it is called a linear equation in two variables. You learned about the solutions of these equations in your earlier classes. In this video, we will learn about another method, which is the graphical method of solving linear equations from the chapter Pair of Linear Equations in Two Variables. Let us first see how to form linear equations in two variables with an example. Nisha went to a carnival and wanted to enjoy the rides on the roller coaster and play the shooting game. The number of times she played the shooting game is half the number of rides she had on the roller coaster. If each ride cost rupees 5 and a game of shooting costs rupees 8, how can we determine the number of rides she had and how many times she played the shooting game, provided she spent rupees 50? Let's see. We first try to represent this situation as linear equations in two variables. We denote the number of rides that Nisha had by x and the number of times she played the shooting game by y. As linear equations, they are written as y equals half x or half x minus y equals 0 and 5x plus 8y equals 50 or 5x plus 8y minus 50 equals 0. The general form for a pair of linear equations in two variables x and y is written as a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. Comparing these equations with the ones we obtained, we get a1 equals half, b1 equals minus 1 and c1 equals 0. Similarly, a2 equals 5, b2 equals 8 and c2 equals minus 50. Students, as mentioned, we will talk about the graphical method of a solution of pair of linear equations. But what is the graphical method? The graphical method is a way to visually solve a pair of linear equations. It involves representing the equations on an xy plane as lines and finding out their point of intersection, which represents the solution to the system of equations. But there are cases when lines do not intersect. What do we do then? For that, we will discuss the types of pairs of lines and their solutions through the graphical method. What are the three types of pairs of linear equations? They are consistent, inconsistent, and coincident pair of linear equations. We will first talk about consistent pair of linear equations. A pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. The lines may intersect at a single point. In this case, the pair of linear equations has a unique solution. For example, 5x plus y plus 8 equals 0 and minus 7x plus y minus 4 equals 0 are two linear equations. We'll first consider 5x plus y plus 8 equals 0 and find the values of x and y. We will keep y on one side So we get y equals minus 5x minus 8. To draw this, we take different values of x and get the values of y corresponding to them. For x equals minus 1, we have y equals minus 5x minus 8, which is equal to minus 5 into minus 1 minus 8, which is equal to minus 3. We get minus 1 comma minus 3 as our coordinates. Similarly, for x equal to 0 and 1, we get y equal to minus 8 and minus 13 respectively. So we get 0 comma minus 8 and 1 comma minus 13 as our coordinates. We will mark all these points on the graph. When we join these points, we see that they form a straight line. Similarly, we will find x and y for the second equation, that is minus 7x plus y minus 4 equals 0. Rewriting the equation as y equals 7x plus 4 and assuming the values for x, we get the coordinates 0, 4, 1, 11 and minus 1, minus 3. We again join all these points and see that they form a straight line. After plotting these lines, we can see that they are intersected at a point on the graph. Can you figure out the coordinates of this point? As we can see, the lines intersect at minus 1, minus 3. This point lies on the lines of both the equations, so we can say that it satisfies both the equations at the same time. Therefore, we say that minus 1, minus 3 is the solution of the given pair of equations. Thus, 5x plus y plus 8 equals 0 and minus 7x plus y minus 4 equals 0 are consistent pair of linear equations. Now students, there is another interesting way through which we can find out if the pair of linear equations are consistent, inconsistent or coincident. We compare the coefficients of the variables of these equations. In case of 5x plus y plus 8 equals 0 and minus 7x plus y minus 4 equals 0, the equations are of the form a1x plus b1y plus c1 equals 0 and a2x plus b2y plus c2 equals 0. Then comparing coefficients of variables of both the equations, we get a1 by a2 as 5 by minus 7 and b1 by b2 equals 1 by 1. Comparing these ratios, we get a1 by a2 is not equal to b1 by b2. That is, 5 by minus 7 is not equal to 1 by 1. Since the ratios of the coefficients of the variables are not equal for the case of these equations, the lines of the equations are intersecting and they have exactly one solution. We conclude that they are consistent. Next, we will talk about inconsistent pair of linear equations. A pair of linear equations which has no solution is called an inconsistent pair of linear equations. The lines may be parallel and they do not intersect. For example, consider the equations x plus 2y minus 4 equals 0 and 2x plus 4y minus 12 equals 0. Solving x plus 2y minus 4 equals 0 first, we rewrite the equation as y equals 4 minus x by 2 and then assume the values of x corresponding to which we get the values of y. For x equals minus 2, we get y equals 4 minus 2 by 2, which is equal to 3. Similarly, for x equals to 0 and 2, we get y as 2 and 1 respectively. The coordinates that we obtain are -2, 3, 0, 2 and 2, 1. We mark these points on the graph and join them. We see that a straight line is formed. Now, we shall solve the second equation. We rewrite 2x plus 4y minus 12 equals 0 as y equals 12 minus 2x by 4. We take values of x as 0, 2 and 4 and we get y as 3, 2 and 1 respectively. The coordinates that we obtain are 0, 3, 2, 2 and 4, 1. Marking them on the graph and joining them will give us a straight line. As it can be seen, the two lines are parallel to each other, which means they will not intersect. Therefore, these lines do not have any solution. We conclude that the lines are inconsistent. Now, as we compared the coefficients of the variables of the equations in the previous example, in this case, we shall compare the coefficients and the constant terms. If their ratio compared are of the form a1 by a2 equals b1 by b2 is not equal to c1 by c2, we say that the pair of linear equations is inconsistent. Let's see. In the equations a1 by a2 equals half, b1 by b2 equals 2 by 4, which is equal to half, and c1 by c2 equals -4 by -12, which is equal to 1 by 3. We can see that 1 by 2 is equal to 1 by 2 is not equal to 1 by 3, which satisfies the condition a1 by a2 equals b1 by b2 is not equal to c1 by c2. Therefore, the lines of the equations are parallel and they have no solution. We conclude that they are inconsistent. We have discussed consistent and inconsistent pair of linear equations so far. We shall now discuss coincident pair of linear equations. A pair of linear equations which have infinitely many distinct common solutions are called coincident pair of linear equations. Such a pair is also called dependent pair of linear equations in two variables. Let us understand this with an example. Take 2x plus 3y minus 9 equals 0 and 4x plus 6y minus 18 equals 0 as an example. We find the solutions of x and y of both the equations and plot them on the graph. We will follow the same steps as we did in the previous examples. We assume values of x and find the values of y corresponding to them. First, we will solve 2x plus 3y minus 9 equals 0. We rewrite this equation as y equals 9 minus 2x by 3. For x equals to minus 3, 0 and 3, we get y as 5, 3 and 1. The coordinates for the equation are -3, 5, 0, 3 and 3, 1. We plot these on the graph and draw through these, obtaining a straight line. Similarly, we write 4x plus 6y minus 18 equals 0 as y equals 18 minus 4x by 6. Assuming x to be 0, 3 and minus 3, we get y as 3, 1 and 5. The coordinates obtained are 0, 3, 3, 1 and minus 3, 5. These are the same points as we obtained from the equation 2x plus 3y minus 9 equals 0. So the line formed with these points will coincide with the previous one. Now we will compare the coefficients and constants of these two equations and see if they are equal. In this case, if a1 by a2 equals b1 by b2 equals c1 by c2, then we can say that the pair of linear equations are coincident or are dependent. a1 by a2 equals 2 by 4, which is equal to half. b1 by b2 equals 3 by 6, which is also equal to half. And c1 by c2 equals minus 9 by minus 18, which is also half. So, a1 by a2 equals b1 by b2 equals c1 by c2, which is equal to half. This means the lines of the equations are coincident and they have infinitely many solutions. We conclude that they are dependent. With this, we have come to the end of this video. Students, remember the equations we wrote in the first example? Your homework is to find out if that pair of linear equations are consistent, inconsistent, or coincident. This table on the screen will help you out in finding the answer. After you have understood the topic, open the EduRev app, study the chapter notes, and take the test of this chapter. Your marks are going to tell you whether you've understood the topic. And not just mathematics, you get amazing courses for social studies, science, English, Hindi, and much more on EduRev. Thank you.